Yeah, welcome to the lecture on electrical circuit analysis. So, today lecture is on mesh analysis. Let us see what is mesh analysis technique to solve the given circuit. So, the lecture objectives is to understand the mesh analysis technique. So, how to apply the mesh analysis to solve the given network or to solve the given circuits. So, mesh analysis. So, first of all, what is a mesh? So, mesh is a closed path in which there is no further closed path. But what is a loop? Loop is a closed path. All possible closed paths in a network is called a loop. In the loop, there may be another closed paths, but in the mesh, there should not be any another closed paths. Now, I can say that all meshes are loops, but all loops need not to be meshes. Simply mesh or loop may be all the closed paths. So, the closed paths we are calling here meshes and loops. So, all meshes are loops, but all loops are need not to be meshes. Okay. So, this mesh analysis is a step by step application of Kirchhoff voltage law. Kirchhoff voltage law, that means a sophisticated application of KVL with mesh currents we are calling as a mesh analysis technique to solve the given network. Now, if you see this network, see circuit, so how many meshes are there? See here, two meshes are there. So, mesh 1 and mesh 2, mesh 1 and mesh 2. So, this is the mesh 1 and that is the mesh 2. So, therefore, here the number of KVL equations to be solved is 2. Because of two meshes, so there are two mesh currents, therefore, the number of KVL equations 2, therefore, the number of equations to be solved is 2. Okay. So, how to apply this mesh analysis? So, this mesh analysis we are also calling as the loop analysis. So, how to apply this loop analysis or mesh analysis? First, the first step is we have to label the each mesh. First, identify the number of meshes. Once you identify the number of meshes, we have to label the each of the mesh. That means, we have to assume the direction of the current. So, we can assume the direction of the current either clockwise direction or anti-clockwise direction, that is up to you. Once you identify these meshes and you label it, then we have to apply the Kirchhoff voltage law in each and every independent mesh. So, if there is any dependent sources, okay, if for n independent loops, so we may write n total that is total equations using the Kirchhoff voltage law around each loop or each mesh. So, loop currents are those currents flowing in a loop. So, they are used to define branch currents. But current sources provide the constraint equations. So, let us see what is this constraint in this mesh analysis technique. Now, first step is you have to identify the meshes, and the next step is you have to label the mesh currents, that is the clockwise direction or anti-clockwise direction, and once third step is you have to apply the Kirchhoff voltage law in all the meshes, and the fourth step is you have to solve the Kirchhoff voltage law equations. Then you will obtain the currents, that is I1 and I2 mesh currents you will obtain. Once you obtain the mesh currents, then it is easy to find out the voltages across that branch. So, what is the voltage across the different elements once you obtain the mesh currents. So, to understand this, so let us solve one circuit. Okay. So, for following circuit, find the mesh currents and use the mesh currents to find Ix, and also we have to find out the Ix, the current flowing in this 2 ohm resistor. Okay. So, what is the first step? So, step 1 is identify all the meshes. So, how many meshes are there? So, this is the closed path is C, this is the closed path, one closed path. So, another one is called another closed path. So, first closed path and second closed path, two closed paths are here. Of course, this from 7 volts, see here, first mesh is 7 volt voltage source covering with resistance and 2 ohm resistor, 6 volts voltage source and 7 volts voltage source. So, this is the first mesh. What is the second mesh? 3 ohm resistor, 4 ohm resistor, 9 volt voltage source, 6 volt voltage source, 2 ohm resistor. This is the mesh 2. So, these are two independent loops. Now, one more loop is there, that is which covering 7 volt voltage source resistor and 3 ohm resistor, 4 ohm resistor, 9 volt voltage source and again 7 volt voltage source. That is a total entire whole closed path. Whole circuit is a one closed path. That is a mesh. It is a closed path, it is a mesh, but it is not as well, it is a loop, but it is not a mesh. So, there are here the meshes are here 2. So, first we have to identify the meshes. Once you identify the meshes, so second step is assign the current. That means, we have to label the current directions. Assign the current to all the meshes. Now, see here second step. See, I have taken the clockwise direction. So, I have taken the clockwise direction. The currents are flowing in the clockwise direction. I1, let us label it I1 and second mesh current is I2. Once you identify this, now the next step is you have to apply the Kirchhoff voltage law around each mesh. Okay. So, first to apply the Kirchhoff voltage law in the mesh 1. Okay. So, what is this? Let us start this minus terminal of this circuit, minus 7 volts, minus 7. That means, what is the Kirchhoff voltage law? The algebraic sum of the currents around any closed path is equal to the 0. So, the algebraic sum of the voltages around any closed path is equal to the 0. This is the Kirchhoff voltage law. So, that means minus 7 volts plus the voltage drop across this current, that is 1 ohm resistor is 1 into I1. So, according to the Ohm's law, the voltage drop across this resistor is equal to V is equal to IR, I into R, the current flowing through the resistor into resistance R. So, therefore, now we have to apply the Kirchhoff voltage in this first mesh. So, sum of the voltages in this mesh is equal to 0. Therefore, minus 7 volts plus 1 into I1 plus this 2 ohm is connected between the two meshes, mesh 1 and mesh 2. Therefore, when you are taking the first mesh, so reference 2 into I1, I1 is entering and I2 is leaving. Therefore, 2 into I1 minus I2 plus 6 volts is equal to the 0. Now, if we simplify this equation, you will get 3 into I1 plus 2 I2 equal to 1. That is equation 1. Let us say equation 1. Now, next one is apply the Kirchhoff voltage law in mesh 2. Okay. So, that means, what is the voltage drop across 3 ohm resistor? 3 I2 plus 4 I2 plus 9 volts plus minus 6 volts plus 2 into I2 minus I1, because now we are applying the mesh analysis in the mesh 2. Therefore, our I2 is reference. So, 2 into I2 minus I1 is equal to the 0. Now, if you simplify this, minus 2 I2 plus 9 I2 is equal to minus 3. This, let us say, it is equation 2. Once you obtain the equation 2, then two unknowns are there, 2 equations. If you solve the 2 equations, then you will get the, now step 4 is you have to solve the equations, then you will get the I1 value and I2 value. So, I1 is equal to 0.13 amperes and I2 is equal to minus 0.304 amperes. So, solving the equation you know very well. So, how to solve the equations? So, you have to use a matrix form, that is a Cramer's rule, you can use that. See, if there are more meshes, 3 meshes, 4 meshes, then it is prefer to use Cramer's rule to solve the big networks. Okay. So, this is the way how to solve the given network or circuit using the mesh analysis. Now, we have discussed the one constraint, that is the, let us see here B, current source provide constant equation. See here. So, to understand that, let us solve one more example. So, mesh analysis. So, since this KVL is valid for phasors, that means AC circuits. So, we can analyze the AC circuit by using mesh analysis also. So, let me take the AC circuit problem. So, practice problem 2. So, calculate the current I naught. So, now let us say this example number 2 problem. So, we have to calculate the current I naught, that is which is flowing in the 10 ohm resistor. Okay. So, this is the first to identify the number of meshes. Here 3 meshes are there. One is covering the voltage source 50 at an angle 0 and 10 ohms resistor minus J4 ohm capacitor, and next one is 5 ohms resistor. So, this is the first mesh. Okay. First mesh covering like this. Now, second mesh is this one, second mesh. Third mesh is this one, third mesh. Okay. So, once you identify the meshes, now we have to apply the Kirchhoff voltage law in each and every mesh. Sorry, first to identify the meshes, second step is you have to label it. Okay. The current direction, see clockwise direction I am assuming, clockwise direction I am assuming. Okay. Next one is I2, I2 is clockwise direction. Next I3, second mesh, I3 is clockwise direction. But here, now apply the Kirchhoff voltage law in the first mesh, third step. So, minus 50 at an angle 0, okay, plus 10 into I1 minus J4 into I1 minus I2 plus 5 into I1 minus I3 is equal to the 0. Okay. Now see, minus 50 plus 15 into J4 I1 minus J4 into I2 minus J5 I3 equal to 0. So, if you simplify that, you will get the equation 1. But here, now coming to the second mesh, so the algebraic sum of the voltage is equal to 0. So, what is the voltage drop in the J8 ohm inductor? So, J8 into I2. Now, when you are coming like this in the clockwise direction, there is a current source. So, because of this current source constraint, so we are unable to apply the Kirchhoff voltage law in the second mesh. So, see minus J4 into I2 plus J8 into I2, that voltage plus this voltage, but what is the voltage across this current source? So, we do not know. So, this is the constraint when you are applying the Kirchhoff voltage law in the mesh analysis. And also if you are applying the Kirchhoff voltage law in this, this mesh, third mesh, minus J6 into I3 plus 5 into I3 minus I2, then what is the voltage across this in the current source? We do not know. So, this is called a constraint, current source, because of current source in the meshes. So, that is the current source in between the two meshes. Therefore, we are unable to apply the Kirchhoff voltage law. Therefore, this is the concept called super mesh concept. Now, here we have to apply the super mesh concept. See here, mesh 2 and mesh 3 form a super mesh as shown in the circuit below. See this one, this circuit. Now, see here, mesh 2 and mesh 3. So, this entire mesh is called, this entire is super mesh concept. Now, see here, how to apply this? See here. So, the voltage across this super mesh, see, minus J8 into minus J4 I2, see here, minus J4 second mesh, minus J4 plus J8 into I2, next minus J6 plus 5 into I3, see 5 minus J6 into I3, next to. But here this minus J4 and 5 ohms minus J4 capacitor and J5 ohm resistor are mutual elements. Therefore, minus J4 into I2, sorry I1 plus minus J5 minus 5 into I3. So, this one equation 2. So, 3 I1, I2, I3. So, 3 unknowns are there, 2 equations are there. So, it is unable to solve. You should not, you cannot solve the problem. Therefore, you require one more equation. Where is that equation is? So, use the super mesh, that is the, this current source is connected between the mesh 2 and mesh 3. Therefore, I3 is clockwise direction and I2 is clockwise direction. So, current direction is from left to right. Therefore, I3 minus I2, I3 minus I2 is equal to 2 at an angle 0 amperes. So, I3 minus I2 is equal to 0 means, so also I3 equal to I2 plus I2, I3 is equal to I2 plus 2, that is equation number 3. Now, 3 equations are there. So, 3 equations, 3 unknowns. Now, it is easy to solve the circuit. You can use substitution method, or you can also determine from the Cramer's rule to solve this network. Okay. So, you can easily obtain the current I1, I2 and I3. Okay. You solve this I1 and I2, I3, solve the equation, then you will get the I1 and I2, I3. So, this is a homework for you. Okay. So, how to solve this? Cramer's rule delta. So, you have to replace the first one is delta means find out the that is determinant of the matrix. Next, to obtain this delta 1, you replace the first column with this voltage, that is 60 and minus 10 plus J12. This you want to get the I1, and if you want to get the I2, replace the second column with same 60 and minus 10 plus J2 vector. Then you can easily find out this I1 is equal to delta 1 by delta. If you want to find out I2, I2 is equal to delta 2 by delta. Then you will get the I1. Otherwise, if you want to find the I1, you substitute the I1 in the any equation, equation 4 or 5, then you will get the I2. Okay. So, this is the way to solve the given network or circuit by using mesh analysis. Okay. Thank you. We will join in the next class.